Okay. So, in last class we have talked about that covariance methods for linear predictions, and we first explained that autocorrelation methods for linear predictions. Okay. So, now we are discussing about the lattice formulation of linear predictions. Okay. So, if you see in whether it is autocorrelation or covariance, we try to solve that matrix phi into alpha, or I can say the phi I k into alpha is equal to phi 0 k. We try to solve that matrix. Okay. So, how do you solve that? We have calculated that phi is nothing but a correlation value in case of covariance matrix. We calculate the correlation value of phi, okay, and then we try to solve this linear equation. Okay. So, whether it is a autocorrelation methods or covariance methods, there is a two step. First step is to compute this phi using correlation for covariance method, using autocorrelation for autocorrelation methods. Next, try to solve this p linear equation, p number of linear equation to find out the value of alpha. So, I can say autocorrelation methods and covariance methods both are two step. Step 1, computation of matrix of correlation value, and then efficient solution of set of linear equation. Okay. Now, this lattice method says that can I combine these two steps, that says that I do not want to use that autocorrelation compute correlation and solve the linear equation in two separate steps. So, I want that can I combine these two steps? Yes, it is possible in case of lattice formulation, combining those two steps and use a simple step. How it is possible? Now, first I have a speech signal, m number of, that is a speech signal, that is a sample, there is a lot of sample is there. Okay. So, there is a lot of sample are there in m equation. So, this is Sm, and this sample is let S m minus I. Okay. So, I can say using this previous I sample, I want to predict this Sm sample. Okay. So, using this previous I sample, I want to predict this Sm sample. Okay. So, if I do that, then it is called forward prediction. I can say it is a forward prediction. Similarly, I can predict this Sm minus 1 sample, this sample based on that this previous sample. So, I can predict Sm based on the I number of previous sample this side, or I can predict this sample based on the m number of sample, I number of sample this side. So, either I can predict Sm from Sm minus I sample from this side, or I can predict Sm minus I from I sample in this side. So, if I predict this one, then the prediction is this direction, this is called backward prediction. So, there is a forward prediction, there is a backward prediction. I can do both way. So, let us how we can do that. I am not explaining the slide again. So, what is that linear prediction equation? If the system is linearly predictable, then equation of the system, that H z transfer function of the system is gain is a 1 minus k equal to 1 to p a k or alpha k, I can say z to the power minus k, or I can say a k or alpha k, whatever. Okay. Now, if I say that what is the so this this one is the error filter. So, this is AZ. So, I can say AZ, let this one is AZ. AZ is 1 minus k equal to 1 to P alpha k z to the power minus k. This AZ is called error filter. AZ is the error filter. I want to use ith order predictor, or say the ith order predictor. Then I can say Aij is nothing but a 1 minus k equal to 1 to I. It is a pth order predictor. If I say it is ith order predictor, it is nothing but a alpha k z to the power minus k. Okay. So, what is forward prediction? Forward prediction is says that SM, or I can say that if it is I have predicted error, forward prediction error, EM is nothing but a original signal, original sample minus estimated sample. Is the prediction error? Okay. So, if it is, this is my original sample and this is my predicted sample. So, this is nothing but a SM minus what is predicted sample, this one, k equal to 1 to I alpha k I s of m minus k. Okay. In Z domain, I can say Ez is nothing but a Sz minus k equal to 1 to P alpha k S z into z to the power minus k. Or I can say this is nothing but a Az into Sz, or I can say Aij into Sz. If I take Sz, so this is, if I take the Sz, then Sz into 1 minus k equal to 1 to P alpha k z to the power minus k. Okay. So, I can say forward prediction error Ez is nothing but a Sz into Aij. Aij. Now, I want to say the backward prediction error. So, what is backward prediction error? I want to estimate Sm minus I from previous I sample. So, I can say Sm minus I is the original sample minus estimated sample k equal to 1 to I alpha k S of m minus I plus k. I want to predict, if I see this here, I want to predict this S m minus ith sample from the previous sample. Okay. So, if it is that, then I can say this is nothing but a Bi or Bm, Bm. Okay. So, Bm, that original sample minus estimated sample value is the prediction error. So, I can say B, if it is ith order predictor, so I can say Bij is equal to, I take the z domain, Sz into z to the power minus I minus k equal to 1 to I alpha k Sz into z to the power minus I plus k, z domain. So, I can say it is nothing but a z to the power minus I. If I take and Sz, if I take out, then it is 1 minus k equal to 1 to I alpha k z to the power k. if I write z to the power k is nothing but a z to the power minus, if I say z to the power k is positive, so I can say z to the power k is nothing but a z to the power minus 1 to minus k. So in that case I can say this is nothing but a z to the power I sz into b I z to the power minus 1, or I can say it is nothing but a ai, sorry, ai z is nothing but a z. So it is 1 minus k equal to 1 to I alpha k z to the power minus k. So here instead of z to the power minus k I write and put a z to the power minus 1 inside. So I can say it is nothing but a ai z to the power minus 1. So I can say bz is nothing but a z to the power minus I sz into ai z to the power minus 1. So this is forward prediction error, this is forward prediction error, this is backward prediction error. Okay. If it is that, then forward prediction error, backward prediction error is okay. Now think about the Levinson recursion. What are the Levinson recursion said? In Levinson recursion, I am not explaining in the boards, it is written in the slides. If you see, step 1 e to the power 0th order predictor is nothing but a R0. So 0 0 alpha 0 0 is equal to 0. Then you know that there is a 3 iteration, one is weight factor, ith pole model Ki, then alpha I Ki is equal alpha I equal to Ki, then alpha j I is equal to iteration, then update the mean square error. So those are the 4th prediction is used in Levinson recursion. So I can say that let Levinson recursion take this one, alpha I is equal to Ki. Okay. Similarly, alpha j I is equal to alpha j I minus 1. Levinson recursion said that current step can be estimated from the previous iteration. So it is previous iteration alpha value minus Ki into alpha I minus j I alpha I to the power minus 1. Okay. So this is the Levinson recursion. Now think about in here. What is Aij? Aij is nothing but a 1 minus k equal to 1 to I alpha k z to the power k minus k. I can write this one as a 1 minus k equal to 1 to I alpha k I minus 1 previous iteration, alpha value of previous iteration z to the power minus k minus z to the power minus k minus ki into z to the power minus I. This is I minus 1. So I can say k equal to 1 to I can say k equal to 1 to I minus 1 alpha k I minus 1 predictor it is. So it is not ith or I minus 1th iteration z to the power minus k minus ki into z to the power minus I. So if I do it the sum k equal to 1 to I, then this will be summed together. So it will be same as this one. Okay. So I just from the summation term only one alpha k z to the power minus I term, ith term I have taken out. Okay. So this is nothing but a 1 minus k equal to 1 to I minus 1 alpha k I minus 1 z to the power minus k minus ki alpha I minus k I minus 1 z to the power minus k I can write this one minus k I z to the power minus I. Why I write this one? I write alpha k I minus 1 from here. Alpha k I minus 1 I can write in term of alpha k I minus 1 minus k I into k I minus j. Sorry, this is alpha k I minus k into I minus 1 z to the power minus k. Okay. So, alpha k instead of here j I put instead of j k. So, alpha k I minus 1 equal to alpha k I minus 1 minus k I into alpha k I minus k I minus 1. That is why I am right. I minus k I minus 1 into z to the power minus k. Okay. Sorry, z to the power minus k is here. So, it is okay. Now, if I do that 1 minus, I can put that value 1 minus k equal to 1 to I minus 1 alpha k I minus 1 z to the power minus k. This is one term. I can write. Another term is, if I take that this sign, this is minus, minus minus a plus. So, I can say plus k equal to 1 to I minus 1 k I alpha I minus k I minus 1 z to the power minus k I z to the power minus I. Okay. If I see this term 1 minus k equal to 1 to I minus 1 alpha k I minus 1 z to the power minus k, it is nothing but a I minus 1, okay or not, I minus 1, and then if I put the same thing here also, if I say this is the one term, second term is this one. So, if in the second term, if I say k I and k I, so I can say k I is here, then I can say k equal to 1 to I minus 1 alpha k I minus 1 z to the power minus I plus k. Okay. Or okay, I will do it here. So, I can write from here that is equal to 1 minus k equal to 1 to I minus 1 alpha k I minus 1 z to the power minus k. This is one equation, this part, and another equation is minus minus plus k I I put the sum also here. So, summation of I is equal to k equal to 1 to I minus 1, this sum minus minus plus k I alpha I minus k I minus 1 z to the power minus k minus k I z to the power minus I. K I z to the power minus I. Now, if this here, if I say that k dash is equal to I minus k, k dash is equal to I minus k. So, if I put k dash is equal to I minus k, so I can say this is k dash is equal to I minus k, k I k equal to 1 to I minus 1 and k dash is equal to I minus k. So, k dash is equal to I minus 1 to I. If you see here, so this you know, so k dash is equal to I minus 1 to I alpha k I minus 1. So, I minus k is equal to, since this there is a I minus k, there is, so I can say k dash is equal to I minus k. If it is k dash is I minus k, so what is k? K is nothing but a k dash. So, if it is k varies from 1 to I minus 1, k varies from 1 to I minus 1. So, if I instead of k, if I put it, let us this term is there plus, instead of k I put k dash. So, I can say k dash is equal to k minus 1 or k dash, sorry, k dash is equal to I minus 1 to I alpha k, ki will be there, alpha k I minus 1 ki into alpha k I minus 1 into z to the power minus k. So, z to the power minus I plus k minus ki z to the power minus I. So, if I say this term will be same, then this term will be ki. If I take minus sign here, then this will become this side ki z to the power minus I. If I take common, then what will happen? 1 minus this term. So, 1 minus k equal to I minus 1 I alpha k I minus 1 z to the power plus k and this term. So, finally, this will be 1 minus k equal to 1 to I minus 1 alpha k I minus 1 z to the power minus k minus this term. So, there is two term. If you see the slides, there is a two term, one is this one and another is this one. So, if I say this is I minus 1th order predictor, so I can say this is nothing but a I minus 1 z minus ki z to the power minus I into, since it is z to the power plus k, then I can say it is nothing but a I minus 1 z to the power minus 1, I minus 1 z to the power minus 1. So, I can say that predicted the error filter Aij can be expressed as I minus 1 z, previous iteration I minus 1 z minus ki z to the power minus I minus 1 z to the power minus 1. Okay? If it is that, then what is forward prediction error? So, I can say Ez or I can say Ez is nothing but a Ai. So, instead of Ai, I can put this one. So, Sz into I minus 1 z minus ki z to the power minus I minus 1 z to the power minus 1. Okay. I just put the value of Aij. So, I can say it is nothing but Sz into Ai minus 1 z. So, it is Ei minus 1 z minus ki into z to the power minus 1 I minus 1, or I can say z to the power minus 1 Bz. What is Bz? Z to the power minus I Sz into Ai z to the power minus 1. So, if it is C, ki z to the power minus I is okay. So z to the, so if I want to write in term of Bz, I have to write z to the power minus 1 into z to the power I minus 1. Okay. I take 1 outside. So I minus 1 and minus 1. Then I can write a I minus 1 z to the power minus 1. So if you see this term is nothing but a Bz. So I can say it is nothing but a z to the power minus 1 Bz. If it is Bz, so I can say the forward error in time domain, if I express in time domain this terminology, so I can say Em, or I can write Em time domain Ez Em e to the e I minus 1 m. So I can say it is E I m is E I minus 1 m forward prediction error minus Ki into z to the power minus 1, it is there, into B I minus z. So it is B I minus z. So it is B I minus 1 m. So if it is z to the power minus 1 is there, I can write minus 1 here. So I can say m, or I can write clearly B I minus 1 m minus 1, because z to the power minus 1 is there. So Bj B I minus 1 m, one sample delay, B I minus m minus 1 sample delay m minus 1. So this is the forward prediction error. Similarly, if you said Bij, if it is Bij is equal to, if I want to replace this Aij in here, then what I will get? I get Bij is equal to z to the power minus I Sz into Ai z to the power minus 1. Okay. So now I can put same Aij value, instead of z to the power minus 1 I can put here. If I put that, then I get z to the power minus 1 B I minus 1 z minus Ki E I minus 1 z. If I put this Bz value, this Az value in here instead of z to the power minus 1. So from this equation I can get Bm is nothing but a B I minus 1. So Bim ith order prediction m minus 1 z to the power minus 1 is there, minus Ki into E, that means E m I minus 1. So this is called forward prediction error, this is called backward prediction error. So I can easily say forward prediction error, ith iteration forward prediction error is equal to I minus 1th iteration forward prediction error minus Ki into B I minus 1 m minus 1, where Ki is the Parker partial reflection coefficient. Okay. So I can say the forward prediction error can be expressed in terms of previous forward prediction error and backward prediction error. Similarly, backward prediction error can be expressed in terms of previous backward prediction error and previous forward prediction error. Okay. So next class we want to discuss about how we draw the signal flow diagram. What should be the pictographic or signal flow diagram of these two equations. Okay. Thank you.